In this lesson, we'll talk about the public key infrastructure, or PKI. So what is a digital signature? It's essentially a digital equivalent to a handwritten signature. It binds the signatory to whatever type of digital data, and it's based on the public key infrastructure. It provides integrity, authentication, and non-repudiation. We've got proof the message hasn't changed in transit with the integrity. We have authentication, that's proof who signed it, and then the non-repudiation, the signer cannot deny having signed it. So we'll walk through a digital signature scenario, again, with Alice and Bob. Once again, Alice is writing some type of document. She runs it through a hash algorithm to get her message digest. Then Alice encrypts that message digest with her private key. The encrypted hash is known as a digital signature, and it's appended to the document that's sent to Bob. Bob decrypts the digital signature with Alice's public key, and from that he obtains a hash value that he can compare with the hash value he gets when he runs the message through the hash algorithm on his side. Bob compares the two hashes, and if they match, he knows the document was signed by Alice and it was not altered in transit. So we'll talk a little more about the public key infrastructure and how that's going to work. Now, this is a framework for secure exchange of information between two parties, and it provides assurance of the identity of the other party. It has three critical components: the certificate authority, the digital certificate, and the registration authority. And to have an analogy in how this is going to work, we can use an example of traveling and having a passport. There's a trusted third party, that's the certificate authority, and a passport example, that would be some government agency. And that agency issues a digital certificate, or in this case a passport, that can authenticate the identity of an individual. So for example, we have Bob, he applies for a passport at some trusted agency. Passport is issued, and he uses that to get on a plane because TSA trusts whoever signed that passport. They know it's Bob, it has his picture, and it was signed by the US government, so they trust that's really Bob. Digital certificates work the same way. It's got the same type of information on it that would be on a passport or a driver's license. Here's an example of a digital certificate from Symantec, and the certificate authority was VeriSign. So on their certificate, it shows who it was issued to, who issued the certificate, and when it expires, just like your driver's license or passport would expire at some point. So it has that same type of information. So let's look at digital certificates here, again with Bob and Alice. Alice applies to the certificate authority for a certificate. This might be an organization like VeriSign. And then Alice receives the certificate back from the certificate authority. She can then exchange the certificate with Bob, who can verify her identity with the certificate authority. Once verified, Bob can trust that Alice is really who she is. So that's a high-level overview on how the process is going to work. And we'll dig deeper into how Alice actually gets her certificate next. So now we'll walk through how public key infrastructure operation takes place. And this is going to take place in a couple of parts. We'll start with part one. Part one is receiving a certificate authority certificate. And this is done to verify the certificates that are issued by the certificate authority. So Alice is going to request a CA certificate that will contain the certificate authority's public key. The certificate authority sends their certificate and public key back to Alice. Alice then verifies the validity of the certificate by using public key cryptography. She also follows up with a phone call to the certificate authority, again, to verify that the public key and serial number of the certificates were actually all valid. So there's two different verification steps taking place here. In other words, this first part is essentially Alice getting a certificate from the certificate authority for the purpose of validating the certificate authority itself. For part 2, now Alice is actually going to apply for her own certificate from that certificate authority. She sends her request and her public key to their certificate authority. The CA administrator calls Alice to confirm the submission and confirm her public key. And then finally, Alice receives and installs her certificate. So that's the process that Alice had to go through to get her certificate from the certificate authority. In our previous example, when Bob got the message from Alice that included her digital certificate, this is the process she had to go through to get that. Bob's job now would be to verify with the CA that certificate that he received from Alice, so he knows that's really who she says she is. Now, as far as public key infrastructure, it can be deployed in several different topologies, and we'll walk through these very briefly. The simplest topology for a PKI infrastructure is something called single root topology. Now, it's got its pros and cons. It's a simple design, but it doesn't scale well. And in this particular topology, there's a single root certificate authority that's passing out all of the certificates to the users. And that's also a single point of failure. There's something called a hierarchical public key infrastructure topology, and here we have multiple certificate authorities within the organization. Now, the advantage of this is much more scalable, and then trust decisions can be distributed amongst multiple certificate authorities. And then finally, there's the cross-certified PKI topology. Here we've got multiple certificate authorities, and they cross-certify their own certificates. This gives a horizontal trust relationship as well as eliminating single points of failure. In some instances, in a public key infrastructure scenario, there will be something called a registration authority, or an RA. And this particular device would accept requested certificates and forward them to the CA. So it acts as, say, a proxy or a middleman between the user and their certificate authority. It can distribute the certificates, but it can't issue them. So here in this example, Bob would send a certificate request. It goes to the registration authority that then forwards the request to the certificate authority. The certificate authority then would issue the certificate, either directly to Bob or back through the registration authority. The purpose of this essentially is it distributes the load. It takes a lot of the load off the certificate authority by acting as a middleman. Now, just a couple other things to mention about PKI, and that's PKI standards for integrating PKI services with Active Directory. And there's two standards you should at least be a little familiar with. One is an IETF standard, X.509, and one is public key cryptography standards from RSA Laboratories. And again, these standards are meant to address the issue of interoperability between the public key infrastructure and Active Directory services, or LDAP services. We should also mention enrollment and revocation. And Simple Certificate Enrollment Protocol, or SCEP, automates most of the certificate requesting and installation processes. But there's also revocation. And just like with digital keys, digital certificates also have to be revoked. If the keys that created them become compromised, new keys will be required, new digital certificates will have to be created. Old certificates would be invalid and require revocation. There's two standards that can help with digital certificate revocation. There's Certification Revocation List and Online Certificate Status Protocol, or OCSP. And both can check if certificates have been revoked.